Hey everybody, welcome back to Works on My Machine, where I'm sharing open source demos of different AI experiments and projects that we've been working on. For this week, I wanted to touch on something that came up in our Discord recently, where I realized that there's not that many people sharing patterns and techniques to get LLMs to generate usable code for you. But there's a lot of focus on outlining and talking about the places where LLMs don't work too well. And I think the core of what causes people to run into those situations is treating the LLM and expecting the LLM to actually understand the code, and then getting frustrated when they don't actually generate code based on the understanding. The thing is, the LLMs don't understand the code, but that doesn't matter. You can actually still get them to write useful code for you. It just takes a little bit of extra work and rethinking the way to approach problems. And one of those ways to rethink it is that instead of expecting the LLM to understand the code, thinking about your code as a prompt. And then when you do that, it kind of creates a couple of different situations where you can rely on good prompting techniques to inform the way that you would architecture code. So, for example, things like few-shot examples and in-context learning, structuring your code to take advantage of that leads to really good results. And really leaning into like heavy polymorphic designs and creating component parts where the LLM is going to see example after example of similar patterns tends to do really well. And so there's a lot of words. I'm going to show you what I mean by that here. So in the sublayer gem, we actually have a CLI that you can use for code generation. So if we do sublayer generator, you're going to get a little warning. It's going to cost money. And then let's say a sublayer generator that takes a cucumber feature file and returns a list of user stories with a title, description, and acceptance criteria. We'll choose Gemini and Gemini 2.0 Flash. Going to generate the generator, and you can see here this generator that was generated. It has the output adapter of a list of named strings, of user stories, and gives us an array of objects with a title, a description, and acceptance criteria. And what it generated was, it generated this output adapter, initialize, generate, and prompt, the interface that we expect for sublayer generators. And it can keep knocking these out, and they're usable right away. And so the way this works is in the CLI, we have a sublayer generator that generates sublayer generators. And so you can see here the description is a new sublayer generator code based on the description, and it returns an object of code and file name. All of this will be linked in the post if you're curious to see the prompt. But you can see here what we're doing is essentially telling the LLM, here's what a generator looks like, and then outlining what the interface contains. And it's able to take just your description that you give it, using the description of the interface, and generate a new class with new functionality. And we do the same technique for the if you saw the previous video where I talk about generating actions while I'm sleeping, same idea is happening there, that because we've designed the sublayer generators and actions to work this way, an LLM can see a few examples and generate new functionality based on those examples, relying on that interface. And all this is to say that leaning into polymorphism with the sublayer generator or sublayer gem for generators and actions means that when you generate, when you're building applications with sublayer, the AI doesn't need to understand the entire code base. All it needs to do is just follow the pattern of what this component needs and what this component's interface is, and you can just slot them into the larger system because you could have 100 generators and the system isn't more complex for the LLM. It's actually it actually gains from the more examples that you have versus becoming overloaded. And I think the other important thing here is, like, even when vibe coding, making your requests with this expectation of, I want this architecture to be highly componentized, where each new component doesn't impact each other component that much, where it's very loosely coupled with the rest of the system. And even when you're reviewing the code, to keep that in mind, because if you can rely on the AI just understanding each individual component, you can prompt it to keep adding more and more functionality, and it'll never get overloaded. So I hope that all made sense. I'm gonna, I'll be sharing a lot more of these examples and go into a little bit more detail in the post. But if this seems interesting to you at all, or you want to get into some of these discussions, join us in our Discord, linked in the post as well. And let me know what you think, and let me know if you've seen any other patterns that tend to have these properties where the more you generate the code, the AI actually benefits, rather than gets to a point where the code base can't be worked on anymore. But with that, thank you for making it this far. Hope to hear from you soon. Thanks.